Okay, hello, how are you doing? So I'm going to give you a brief description of what is going to be on section 7.2. Okay, in 7.2, you are going to investigate integration methods for integrating the power of the trigonometric functions. Okay, the sine, cosine, tangent, secant. Okay, there are various methods. I'm going to summarize it for you. Okay, and then you should be able to do the problems in the important sections. We are going to use it quite a lot in future, and it's not difficult if you just don't make it complicated, if you like. So this is going to be 7.2. Okay, 7.2, and you want to integrating power. Okay, we're going to be power function, but the power trigonometric functions. Okay, or powers of trig function, trigonometric functions. Okay, this is going to be the one. Just recall that if you have a power of the trigonometric function from calculus 1, this is the way you can take care of it. So recall that. That is what you have probably learned in calculus 1. Recall that, you see, we want to use substitution. So if you have the integral of sine to the nx, we are going to call the u to be sine x. It's going to be u to the n, but you need the u prime. So if there is going to be a cosine x here, so by u substitution is going to be sine to the n plus 1 of x, okay? And this is going to be n plus 1 plus a constant c. Of course, n cannot be equal to -1. Okay, because you take the u to be sine x, u prime would be cosine x, so it's u to the n. So that gives u to the n plus 1. Okay, so if there's going to be a power of a sine, you need a cosine here. So the other one is going to be the cosine. If you have a power of a cosine, you need a sine here. Because you take the u to be cosine, so u prime would be negative sine. So the answer is going to be integral of a secant. Integral of a cosine is going to be a sine, but there is a negative here. So it's going to be negative cosine to the n plus 1 over x over n plus 1 plus the constant c. If you differentiate it, n plus 1, you bring it down, you simplify it. Derivative of a cosine will do negative sine, negative positive, and 1 down. If you want to have a tangent, you take the u to be tangent x, u prime would be secant square. So you need a secant square of x dx. If you have it, again, use substitution, you take the u be tangent, u prime would be secant, so that's going to be tangent to the n plus 1 of x over n plus 1 plus the constant c. Okay, so if you have a power of a secant, you know that the derivative of a secant is going to be secant 10. So if you have a secant of x tangent of x dx, so the result would be secant to the n plus 1 of x divided by n plus 1 plus the constant c. So these are standard formula that you have to memorize. Okay, you memorize this. So the difficulty is going to be the one that you're going to see. You may not have this cosine or sine secant square or secant 10. So you have to create it yourself. Okay, so we are going to investigate the powers of the sine first to show you how we're going to take care of these. Okay, for the cases that we're going to have over case 1. Case 1, the question is you want to integrate integrate integral of the power of the sine, and they are very similar, and the integral of power of a cosine. You see, in order to take care of it, you need these leftovers to be able to use U substitution and get the result. So what we're going to do, we are going to consider two different cases, even exponent and the odd exponent, okay? So the case one is going to be, okay, the case one, n is odd. If it's going to be odd, it's very, very easy, okay, because when it's going to be odd, so it's going to be something like n equal to the, if you like, 2k plus 1. So this is the way we're going to do it. You see, this is the sine. If it's going to be the sines, you need the cosine. If this is the cosine, you need the sine. So if the power is going to be odd, so this is going to be sine nx dx is going to be the sine to the what? To the 2k plus 1 x dx. So what we are going to do is, this is odd, 3, 5, 7. You pull out one of the sines, you see it's going to be sine to the 2k x. So the leftover over here is going to be what? The leftover here is going to be sine x dx. So what you can see is you should arrange it so that this is going to be your u prime, or this is going to be your du. Since it's a sine, so you need a cosine. It's even number. So what you are going to do, you're going to change it to the cosine. Look at this one. It is going to be the sine of the 2kx. So what you can do is you can rewrite it as sine square of x, then to the qk, to the k. Then this is going to be 1 minus cosine square of x. Okay, everything to the k. So your integral is going to be substitute. So that give you 1 minus cosine square of x, everything to the k, times sine x and dx. So in order to do this integral, you just use the u substitution. Okay, so you're going to let your u to be cosine, and your du automatically would be what? Would be negative, is equal to the negative sine x dx. Then you substitute and you'll be able to do it. Okay, so the big thing is that it's just the power of the sine. So you need a cosine, you need a sine to be able to use substitution. So it's going to be odd, it's the best case. It's odd, you pull out one sine or cosine, the leftover, the power would be even. If it is a sine, change it to the cosine. If it's a cosine, change it to the sine. Okay, so this is going to be case one. I do the case two as well, and then you go for it. Case two is going to be more involved. You have to use the double angle formula. So case two. So what is going to be case two? Case two, if n is going to be even. If it's going to be even, it's going to be like 2k. So what you would like to do now, you have to find the 2kx dx, and the power is even. For this one, you have to use the double angle formula. You see, you use this fact that the sine square of x is 1 minus cosine of the double angle, 2 times x over 2. And if you have a cosine squared, is going to be 1 plus cosine of the 2x over 2. So, you substitute, you change it to the power of the cosine, and then you can, you should be able to take care of it. Okay, so the double angle formula will do it for you. So this is going to be two cases for the sine and the cosine. So I'm going to give you an example. So on the test, probably you will get one from each. So be careful. If you follow the rules, really, that's an easy case. Nothing to worry about. So these are going to be the candidate. Example, would like you to evaluate each integral. Evaluate each integral. A popular case for the odd power is something like integral of cosine cubed or sine cubed, sine to the fifth, at most it's going to be 3 or 5. The 5 takes a little bit time, we do one of these third power, and then, in practice one, we do one of the fifth too. So the power is odd. So what you are going to do, you are going to break one of them, you see. You rewrite it as a cosine squared. You need a cosine here. You keep this one for the u prime. So this is going to be your u. You change the cosine into the sine. So it's going to be 1 minus sine square of x, Pythagorean identity, times the cosine of x. See, this is the way we do it. Now we go back, u substitution, give us the results right away. Okay, so integral of a cosine cube x dx now is going to be equal to the integral of 1 minus sine square of x times the cosine of x dx. Now we can do it with u substitution. The way you're going to operate, you are going to take the u to be sine x, and automatically your du would be cosine x dx. Go back and substitute. So if you substitute here, so your integral is going to be 1 minus u squared times du. So distributed is going to be what? You just integrate it really. Integral of 1 is going to be just u. Okay, this is it. Integral of 1 would be u, and integral of u squared is going to be u to the third over 3 plus the constant c. Now substitute. Your u was sine x. So that is sine x minus sine cube of x over 3 plus c. So the integral of a cosine cube x dx is simply sine x minus sine cube of x over 3 plus the constant c, and you're done. Okay, so the odd power are going to be very, very easy to handle. And you can have a sine cube, to check it for yourself. For the even power, the famous one is, let's go with the sine square first. Sine square, cosine square, you have to use double angle formula. So for this one, the double angle formula, sine square of x would be what? Would be 1 minus cosine of the double angle. This is x, it's going to be 2x divided by 2. Go back, substitute, it's going to be sine square of x at dx, which is going to be equal to, now you get 1 minus cosine of the 2x over 2 and dx. Okay, now you integrate this one, you can break it. Is a 1/2 minus 1/2 cosine of the 2x at dx. So integral of the 1/2 would be 1/2 x minus integral of a cosine is going to be sine. You see, you keep the 1/2. So this is going to be sine of the 2x, but you have to divide it by 2. Remember, u prime. Okay, plus the constancy. So the final answer, integral of a sine square of x is equal to the 1/2 x minus 1/4 of the sine of 2x plus constancy, and then u done. You see, this is integral of the sine square. It's very popular. You're going to use it again in future. Okay, so this is a sine square. I do one more power for you because this is the one that we're going to use in future. How about, for example, cosine to the 4th of x dx? Again, the power is even. You can do it only if you use the double angle formula. It takes a little bit more time. So this is the way you're going to change it. It's cosine to the fourth. We write it down as cosine square of x all squared. Now we substitute. Cosine square would be double angle formula 1 plus cosine of the 2x over 2 all squared. You see, we reduce the power. You have seen these type of things in your pre-calculus classes. Now we square it, the square top and the bottom. The bottom one would be 4. The top, we use the square of the binomial. The square of the 1 is 1. Twice of the first times second plus 2 times 1 times cosine 2 cosine of the 2x plus the square of a second one, which is cosine squared of the 2x. Okay, you can use the FOIL method if you like, if you don't like this method. Now you have to simplify, then integrate it. So this is it. This is going to be a quarter. 2 quarter would be 1/2. 1/2 cosine of the 2x. And this is going to be a quarter cosine of the cosine square of the 2x. This can be easily done, but you have to reduce this one again. So you have to use that square, okay, double angle formula. You have to square it, simplify it as much as you like, or you can, before getting to the integral. And this is the operation of the pre-calculus one. A quarter, 1/2 cosine of the 2x. Now this is going to be a quarter. So use the double angle formula again for this one. Is the cosine square is going to be 1 plus cosine of the double angle. The angle is 2x. You double it, make it to the 4x divided by 2. Okay, now that gives you a nice, we call it reduction of the, reducing the power in pre-calculus. 1/2 cosine of the 2x. And this would give you 1/8. And when you multiply by the second one, that gives you 1/8 cosine of the 4x. And this is it. We have something to simplify. And that's going to be 1/2 and the 1/8. See, that is can be simplified a little bit more to get to the integral. 1/2 and the 1/8, the common denominator, you multiply this one by 4 is a 4/8. Okay, this is going to be, let me just make sure to get it right. That was a quarter, sorry. That is a quarter. Now a quarter and 1/8. That would be 2/8, and the 1/8 would be 3/8, because this is the formula from calculus that I remember it. So that gives you 1/2 cosine of the 2x plus 1/8 cosine of the 4x. You see, we reduce all the power. This is always the case. You have no other choice for the even power of a sine or cosine. This is also used in calculus 3, so make sure you know the method. Okay, so this integral is very easy to operate. Okay, so double angle formula twice to get this number. You see, when it's just sine squared, so we use the double angle formula once. But when it's to the fourth, this is going to be the case. When it's a 6, good luck. It's quite, messy to do that problem. But not a big deal, really. So what I did, basically, this is the integral that's given to me. So what I did, I change it. I change it to what? I change it to the 3/8 plus, you see, I simplify it. That's a geometry part. That's a trick part. 3/8, 1/2 of the cosine of the 2x, 1/2 of the cosine of the 2x, plus, I think it's a 1/8 cosine of the 4x. Okay, 1/8 cosine of the 4x, you see. So now it is easy to integrate. So integrated, integral of the 3/8 would be 3/8x. This would be 1/2. Integral of a cosine is sine. Sine of the 2x, you have to divide by 2, you prime. And that would be 1/8 So that gives you a sine of the 4/8. You have to divide by 4 u prime plus the constant c. So eventually this is the final answer. 3/8 of x plus a quarter of a sine of the 2x plus 1/32 sine of the 4x plus the constant c, and you're done. This is the famous cosine to the 4 of the dx. Okay, so the key is that double angle formula. Well, this integral, it's easy to operate. So make sure you know it for calculus 2 and 3. This cosine to the 4th or sine to the 4th, it's going to be happening. And in this course too, not difficult, but got to be patient to get through that algebra. Okay, so that's the even and the odd power of these two together. Sometimes you may have a combination of both of them, then you have to decide yourself. Okay, so give you another one. Look at this one. It's the same rules, in your book they break it into 4 cases, but you don't need it really. Just think about it the way I talk about it for you. So for example, you may be given something like, how about something like sine to the 6x? Okay, and this is going to be cosine of what? Cosine of cube x dx. You see, look for the odd power. The power of the cosine is odd. Remember, when it's odd, pull out one cosine. That would be your u prime. So you have to change everything else to the sine. So this is how we're going to operate with this one. So this is the given one. You look for the odd power. The power here is odd. So break it. So that gives a sine to the 6. This is going to be cosine squared times the cosine of x. Okay, leave this one because this is going to be your u prime. If the u prime or the differential is going to be cosine of x, so you need sine because you want to use the u substitution. This is already sine to the 6. This is cosine squared. Change the cosine into the sine. Okay, so once more, it's going to be sine to the 6 of the x. Change this one into the 1 minus sine square of x, and keep this one for your u prime, you see? If you take u to be sine x, you can do it right away. So I'm going to simplify it again. I distributed, you distribute this one. It's going to be sine to the 6 of x, but sine times by the cosine, minus sine to the 6, sine square would be sine to the 8, sine to the 8 of x times cosine, see? Go back. Remember, originally, you'll be given this one, sine to the 6x cosine cube of x dx. So it's going to be what? It's going to be sine to the 6x cosine x dx minus sine to the 8x cosine x and dx. You see, u prime, u all over the places. This is it. You take the u to be cosine. That's the formula that we talk about it. And this is going to be your u prime or the du. So the first one is going to be sine to the 7. This is just the power rule, u to the 6, divided by 7 minus the next one is going to be sine to the 9 of x. 9 of x over 9 plus the constant c, and then you're done. You see, don't make a mess if you like. As I told you, as soon as you see the odd power of a sine or a cosine, break it. Break it, and there's going to be leftover of the cosine. That's very good because this is going to be your du or u prime. So we have to change everything else into the sine. So that's as a cosine square, I change it to the 1 minus sine square. So when you distribute it, you'll be able to do it. Okay, so this is the integral of the power of the sine and the cosine. Okay, dealing with the power of the sine and the cosine. If the power is even, you have to go through the double angle formula. If the power is odd, that's good one. You break that odd power, you see, there's going to be leftover of a cosine or sine. So look at this one. This is your u prime. This is your du. So everything else must, since it's a cosine, everything else must be in terms of the sine. So then u prime u then give you the result right away. Okay, so that's the case with the sine and the cosine. Okay, again, just get the general idea, general instruction rather than 4 cases, 5 cases like it is in your book. And this is the way we're going to operate. Okay, so that was the answering this question of okay, so we answered the powers of, so that was the starting point, case 1. Integrating sine, cosine, repeat it again. If these powers are odd, the best, we break it and then u prime. If the power is going to be even, you have to use the double angle formula. Okay, so that's for the sine and the cosine. Now, the other case that we are going to consider is going to be what's going to be integral of the power of the tangent, which is very easy. Tangent is very easy. It takes a little bit of time if you have the higher power, but otherwise it's easy case. So the next problem is going to be, we want to integrate this one, power of the tangent. See, that's one. To get the power of the tangent, again, you need u prime. Derivative of a tangent is secant squared. You don't have the secant square. So what you have to do, you have to take a secant square out of these. So this is the way you're going to do it. A special case is going to be, just to recall, you need this one. Recall that you need the fact that we did this one. Tangent of x dx, this integral is ln of the absolute value of a secant x plus c. You have to memorize it to use this one. For the other powers, we can do it. Okay, so that's tangent. So for the rest, when n is bigger than 1, so what you're going to do, you need a secant squared for u prime. So break this one. You see, this is the way you're going to break it. If it's not going to be 1, it's start with a 2, so you can do this one. So this is nx. So break it, you take 2 out of the tangent. So make it tan squared. Now change this one to the secant. You know that 1 plus tangent square is secant squared. And the tangent square is secant square minus 1. So this is going to be, I'm sorry, you pull out 2, so it's going to be n minus 2. Because you pull out a 2 here, square. So this is going to be the tangent to the n minus 2. Now change the tan square into the secant square. It's going to be secant square of x minus 1. A relationship between, you know that 1 plus tan square is secant square. And that's it. You take u to be, that's x. So you are going to let u to be 10. You see, then the du is going to be secant square of x dx. When you substitute here, easily can be done. But it takes times for the powers. You cannot do it right away. Okay, so I'm going to explain a couple of them for you so that you can see it. So example are going to be, we wanted to evaluate each integral. Evaluate each integral. You need the first power and the second power. I've already given you the first power. So I give you the second power too. So let's write this one first, tangent square. Okay, you need secant square. This is already tangent square. Tangent square is secant square minus 1. So you are going to rewrite it. That's integral of a tangent square of x dx. We rewrite it as what? Secant square of x minus 1. That's it. Integral of a secant is 10. Integral of 1 is x plus the constant c, and you're done. Okay, that's a tangent square. But you have to know up to the fifth power. Let's see what would happen to the tangent cubed. Again, you need secant squared. You can get the secant squared plus tangent squared. So you break this one as I talk about it here. So that's it. This is a tangent cube. Take out one tangent squared. So the leftover would be 1. Now change the secant into the secant squared minus 1. So it's going to be tangent of x times secant squared of x minus 1. So go back to your integral. So it's a tangent cube of x dx. Substitute. If you substitute, that give you what? That give you tangent of x, secant square of x, distributed minus tangent of x dx. Okay, I just multiplied the tangent inside. So we have two integral. It's going to be integral of a tan x secant square x dx, the first one, and minus integral of a tangent of x dx. That's it. Okay, over here, this is it. This is going to be u du. You know that if you take this one to be u, and this is going to be your du. So it's going to be u squared over 2, which is going to be tangent square of x over 2, minus integral of the tangent. I've already talked about it. It's minus ln of the absolute value of a secant x plus c, and then you're done. Okay, so that's a tangent cube. So if you want to do the cube, you end up 2 done. You end up with the tangent, and you should be able to find it's always the same. For the other power, I give you one more. I give a tangent to the 4 so that you see how we're going to handle those powers are very similar, of course. So let's see. How about the tangent to the 4th? Okay, but again, you need the secant square. So pull out the tangent square as we talked about for the other one. You break it, tangent to the 4th. You break it into the tangent square of x times the tangent square. You change this one into the secant square like the other one. So it's going to be tangent square of x, and this is going to be secant square of x minus 1. Now, if you distribute it, you can do it right away. So what we have, this is the given one. So it's going to be integral of, you distribute this one, tangent square of x, secant square of x minus tangent square of x, all dx. Okay, so that's tangent for any power of the tangent. You break one tangent square out. That out would be changed to the secant square minus 1. That will help you. Now you distribute, you see this is it. You take u with tangent, your prime is secant square, so that gives u cube over 3. Tangent square, you have to go back and repeat it again. You see, we already done this one. It's always the case. It's going down 2 powers. You cannot find it right away. Okay, so what we are going to do, so we end up with the integral of a tangent square of x secant square of x dx, that's one of them, and minus integral of a tangent square of x dx. Okay, you start with the tangent to the fourth, you end up with the tangent. You start with the tangent cube, you get to the tangent to the first. Now we find these two. The first one is easy. Okay, it's just the standard formula that we talk about it. Because this is going to be u, and this is going to be your du. So it's going to be u to the third over, it's going to be tangent to the third over 3. Okay, if you like, press the constant c. Or the tangent is squared, you have to change it. Change it to the secant square of x minus 1. We did it before. Integral of a secant square would be tangent. Integral of 1 is x plus the constant c again. So go back, substitute, that give you integral of, but integral of a tangent to the fourth of x dx. Tangent to the fourth would be tangent cubed over 3 minus tangent squared. It's going to be minus tangent of x plus the constant c, and you do that. You see, as if you go to the tangent to the fifth, it would be reduced to the tangent cube, then you have to do the tangent cube. You cannot do it right away. We call it a reduction formula. So this means it's going to be done in two steps, if you like, not just the one steps. Okay, so the tangent is easy because you don't have to divide it into two parts, the even power or the odd power. Okay, now the tricky one is secant, the most popular one, or calculus 3, or there is a polar functions that we're going to talk about it at the end of the course. This is going to be very important. Okay, so how are we going to take care of, so that was the part 2, this is part 3. You want to integrate power of a secant. You see, power of a secant. This integral. Secant is tricky. It's not like tangent. You have to divide in two parts, even power and the odd power. Okay, so let's see what will happen. Case 1. Case 1, n is even. Okay, even like 2k. You see, your difficulty is if you want to use u substitution, when u is secant, the derivative of a secant is secant 10, which is difficult to create here. So what we are going to do is going to be, when it's going to be even, remember for the even power, we pull out one secant squared, that would be u prime. U prime for what? For tangent. So you change everything else to the tangent. Let me show you. You see, this is the case. If you have the even power. So what we can do is, you pull out one secant squared, you keep this one for u prime. So what's going to be the leftover? Leftover is also even power again, because 2k minus 2 is even. So what you're going to do, you are going to change this one into the tangent. So you're going to use this. Use the fact that the secant square of x is equal to what? 1 plus tangent square, remember, is secant square. So we're going to do exactly, we replace the secant square, this secant square here, by 1 plus tangent square. So this is going to be your result. That's a 2k. Over here, that gives you 1 plus tan square of x to the k minus 1, if you like, and then secant squared. So you let u to be tangent, and the du would be secant square of x dx, you'll be able to do it. So basically, the idea is for the even power of a secant, You cannot create that secant tan. So what you do, you change it to the tangent, in fact, okay? The even part, you can change it to the tangent right away. Okay, yeah, even don't do this one at the beginning, but it's easier. You pull out the secant square, the leftover, change it to the tangent using this formula. So then u prime give you the result right away. Okay, so this is going to be when the n is even. What would happen if the n is odd? You have to use integration methods. Okay, n is odd, you have no other choice. Use integration method. Integration by parts. For the even, okay, for the odd exponent, you can do it. So I'm going to show you, there are some very popular example of this one. With the even power, we can go with this, okay? So example, for the even, we can go with the integrate. We can go with the secant to the fourth. You can also go with the secant to the sixth. It's safe. You can use any power. Okay, when it's even, you have to pull out one secant square, change everything else to the tangent. So this is the way you are going to simplify it. That's a secant to the fourth. You pull out one secant square here, you keep it. Left over, that's a 4, so that gives you secant square. So it depends. If it's a 6, you keep the secant square, then we get the leftover to the 4. Now change the outside one to the tangent. So the outside one would be 1 plus tangent squared of x times secant squared. Now it's ready. Okay, u prime, you take the u with the tangent, u prime would be secant squared, then you'll be able to do it right away, okay? So the original one was secant to the fourth of x dx. That's originally. So we change it into what? 1 plus tan square of x times secant square of x dx. Distributed. Secant times 1 would be secant squared and plus tangent square of x, secant square of x. You see, nicely you have a tangent and a secant square. So we go on, break it. The first one is integral of a secant square. So in order to answer the problem, remember the problem is secant to the fourth. Now we change it to the two parts. One part is secant square of x. The other one is going to be tangent square secant square. Secant square, you know that the integral of secant square would be tangent. And over here, you take the u to be tan. This is u prime or du. So it's like u squared, which is going to be u to the third power over 3, okay? Nicely, it can be nicely done for the even power of the secant. You give me any even power, I can do it right away. So we break it into these parts. So we break it into two integral. I repeat it, sine square dx, secant square plus tangent square of x, secant square of x dx. Now it can be done right away. Integral of the first one is tangent. Okay, because you have to have a tangent secant square. And this one over here, just use substitution. You see, this is your u, and this is your du. So it's like u squared. So u to the third would be tangent to the third of x over 3 plus the constant c. So that gives you the final answer. So this is the integral of a tangent. That gives you tangent x, and that gives you tangent cube of x over 3 plus c. There are some other method to do this one, but that's a safe and easy method really for tangent to the to the even power. Okay, So that would be easy case to apply. Now the odd power. This is going to be a tricky one. So I just remind you the next example. Just recall for the next one. We give a remark. You have to make a note. You need this one. If you want to do any power of the odd power of a secant, you have to go from this. You see, I did this one before for you. Integral of a secant x dx is what? Is the ln of the absolute value of a secant of x plus tan x. So you have to keep this one in mind when you want to do odd power of a secant. Because whatever odd power that you start, you see this is the first odd. The next one is sine cubed. That sine cubed by integration by parts would end up with a sine secant x. The next one is secant to the fifth. You have to reduce it to the secant to the third, then to the secant. Okay, so it takes times. I just know a couple of them would be fine. So what we'd like to do is, we would like to find this one, integrate this. You know, if you take, I told you, the future courses, differential equation, if you're measuring physics or engineering, there are a couple of differential equations that would end up with the secant cube. So it's going to be used quite a lot, secant cube and secant. You have to add them handy for future. Okay, now it must be done by integration by parts. Now remember, so we've got to be careful to see how we're going to pick those integration by parts techniques that we're going to have. Okay, so this is going to be the solution. Now, remember, there is one part, you know, whatever you take for the u, you differentiate it, then the other one you integrate it. So the way we are going to do it is we rewrite it. You have to pull out a secant squared. You see, a secant squared out. So this is the secant of x. You pull out a secant square of x dx, always. Now, we are going to take this one to be u, secant. The leftover would be du, secant square of x dx, always, always. So if this is to the fifth, you pull out the secant square, this would be secant cubed. Okay, always. You need secant square dx to call it dv. Okay, that's a u, sorry, that's a dv. Because you have to integrate. Remember, when we get the u, you have to find the du, which is secant tan. And this is, you integrate the secant that give a tangent. Okay, when we have the u, you remember we differentiate it. So derivative of a secant is secant tan. And when we have the dv, we have to integrate it. Now go back and write your integration by part. You'll be surprised at what you are going to have. Look at this one. Carefully, of course. So that gives us secant cube of x dx. That's the one that we needed. Integration by parts, uv is the secant of x, tangent of x, minus v du. This is v du. What's the du? The du is secant square of x dx. Okay, uv that gives secant tan minus v du. Oh, I'm sorry, I made a mistake. v du. v du is, it's a secant, that's a v tangent. So it's going to be secant tan is going to be secant x tangent of x and the dx. You see? Always when we get the second one, you see tangent, and the tangent will be the tangent squared. So it's going to be secant of x tangent of x minus integral of tangent square of x okay, secant of x dx. It's always the case, you know, you end up with the tangent squared. So you have to find the integral of this new one with that tangent square that you have all the time, you see. Tangent square of x secant of x dx. So what we do, we replace the tangent into the secant square minus 1. So that gives secant squared minus 1 times a secant of x dx. If you multiply it, you'll be surprised. You see secant squared times secant would be secant cube. Take you to the original one. It's going to be secant cube of x minus secant squared. Secant cube times secant. So if you distribute it, that gives you secant cube of x dx minus integral of a secant of x dx, you see. But remember, this is the one that you are interested in. So go back, substitute. You take this one and you substitute it here. So remember, you start with the secant cube of x dx, which is equal to what? Is equal to the secant tan, secant x tangent x minus this integral. But you simplify this integral as what? As integral of a secant cube of x dx minus integral of a secant x dx. A little bit of algebra. You apply this negative sign and then you simplify it and you're done. Look at this one. This is what we have here. Secant cube x dx. And this is going to be secant x tangent x minus integral of secant cube x dx plus integral of secant x dx. Remember, you are looking for this one. You see, this is one, and you have another one here. So what you're going to do, you're going to pull this one to the other side, and then you'll be able to find the result. It's like I minus I, if you like. If you pull this one, add it to the other side, that give you 2 times integral of a secant cube dx. And integral of a secant, we know it, and then you'll be done. It's always the case that you have to do this manipulation, if you like, to pull out the secant cube. And the way we did it, there was a tangent. There's always a tangent square here, always, for any of these powers. So we change the tangent square to the secant square minus 1. And when you multiply, you get back to the original power. You see secant cube. That gives you secant cube, secant cubed minus secant. Now add this one to the other side. That make it to the true integral of. Okay, so it's going to be true integral of secant cube x dx equal to, it was equal to what? Equal to the secant x tangent x plus integral of a secant. So it's going to be equal to the secant x tangent x plus integral of a secant x dx. You know, the integral of a secant x is going to be, so that's a secant x tangent x, and as we did this one before, ln of the absolute value of a secant x plus tangent x plus the constancy. Of course, you have to divide by 2. That gives a very famous formula. That's a very well-known formula that we proved it. So that gives 1/2 secant of x tangent of x plus 1/2 ln of the absolute value of a secant x plus tangent x plus the constancy. Very famous formula for the integrations. Okay, so be careful. Remember, you know, to how we are going to do it for the secant cube. I know that there are going to be quite a lot of this, you know, and you just get the general idea, really, that in case in future, if you want to do it, especially secant cube, because in future you may use your calculator or this type of okay, operations and get the result. But you have to know the general idea of how we operate really for these type of problems, or those even exponent that we talk about. Okay, so that's the power of the secant. I'll give you one more, and that would be section 7.2. And the last one is a combination of sine, secant, and the tangent. Sometimes this is going to be tricky, but it's not really. If you go a couple of problems, then you get the idea quickly of how would you handle these type of problems. These are going to be a famous type. This is a product of the tangent and the secant when the power of both of them are odd. I just want to remind you how we're going to handle this. You see, if the power of one of them is even, you pull out, for example, one tangent square, change it to secant square minus one, you do it. Or if the power of a secant is even, you pull out one secant square. But the question is going to be, both of them are odd. So you cannot pull out the secant square or the tangent square. Now, but what we can do is, you see, the good thing is, if you take one tangent out of this, you change it to the tangent to the fourth, which is even. And if you pull out one secant of this one, you change it into, okay, secant squared. And that would be something would be easy to handle. So that's the case when both of them are odd. So this is the way we are going to do it. So this is the given one. Okay, pull out one tangent, one secant, because both of them are odd. Okay, and the dx, put them together. So what is this? Secant 10. You know that secant 10 is derivative of what? Derivative of a secant. So if you change everything else to the secant, then you'll be able to do by U substitution. So what's going to be the leftover? This would be tangent to the fourth. And that would be secant squared. You already got the dv if you like. So you need secant. Go and change to the secant. You already got the secant squared. Change the tangent. Okay, so this is the way we are going to do it. Remember, tangent square is secant square minus 1. So this is going to be secant square minus 1 square. Okay, secant square minus 1 is tangent. Tangent square is, okay, this is tangent square with tangent to the fourth. And this is secant square. And that would be secant 10. Tangent secant dx. That's it. You see? If you take u to be secant, then this is going to be your du. And you'll be able to do it right away. I'm going to distribute it. It takes a little bit to do it because that's a square. You have to square this one. You've got the patient. So that gives you secant to the fourth of x, the square of the first, minus twice of the first times secant, secant squared, plus 1, then multiply by secant square of x, then multiply by the tangent secant dx. Work on this. Distribute it. Because this is your u prime, you need the secant. So if they multiply these two together, give you secant to the 6 minus 2 secant to the fourth plus secant squared. Okay. And this is going to be tangent secant. That's it. You see, if you take u to be secant, I just show you that if you take u to be secant of x, so the du is secant 10. So that's it. So this first one is like u to the 6, u to the 7, secant to the 7x over 7. Done. minus 2. This is going to be just u to the 4th. So that gives you secant to the 5th x over 5. Done. This would be what? Like u squared. So that gives you secant to the 3rd x over 3. Done. Plus the constant c. You see? Nice integral. You can rewrite it if you like. And this is going to be secant cube of x over 7. And it's minus 2 secant to the 5th x over 5. And this is going to be secant cube of x over 3 plus the constant c, and then you're done. See, it's very nice integral. But the idea, as I told you, the idea is both power are odd. So you have to change one of them to the other one. You have to change either tangent to the secant or secant to the tangent. You can do it if the power is going to be even. In this case, you don't have the even power. So that's why we take one tangent, one secant out. Then the one that you took give you the derivative of a secant. So that's why you change everything to the secant, because both of powers are even. So what I did, I changed the tangent to the secant because I've already got the u prime. So it's going to be u prime all over the places to get this type of ideas. Okay, so that's roughly what you need to know, really. Read it carefully. I just put them together. And then you should be able to do any of these problems, of these sections. And this is the way you remember it. The idea of it's always you're looking for the u substitution. So you need to have the u and the u prime, if you like, or the du. Okay, so I will give you one more section. That's 7273. I give you another recording. And then this is, the other one is going to be, there are some radical expressions that we can use trigonometric substitution to change it. Okay, and they are going to be useful. So that's a section 7.3. And this is where we are going to give you test 1. So I post another recording for you for that section 7.3 and your practice test number 1. Okay, and also I give you a sample besides that, the practice one, so you can be able to practice to get there, because your test is going to be, I think it must be a week on Tuesday. Yes, maybe next week. That's it. It should be next week. I double check it again, but anyway, I posted another recording and the practice one, and I go over the solution to that practice one too. Make sure you get it right. Okay, so study these are the dense sections, but they're not bad. We get it. We talk about 2 more sections, 3 more section of integration, and then for the rest of the course it's going to be quite different. We get the sequences and series. Okay, I'll post this recording. Have a look at it quickly. If you have any question, let me know. I'm looking out for your quiz, and I finish it before the end of this week, so that you can idea, because this quiz will be repeated again. Okay, I'll look at it for the next couple of days. I think I did question number 1 or number 2. So I'll check it quickly. And then you already got your assignment points. Okay, if you've done it, you get it. So that's your first sets of assignments. You are not going to have any assignments for the test day. So the next sets of assignment would be in 4 weeks times. Okay, have a good one and take care. Bye-bye.